Hello everyone, welcome to section 1. Now in this section, I'm going to talk about various general concepts. Now please bear with me in this section because I'm not going to show you any hands-on. This is basically the general concepts wherein we'll take a step back and try to understand how things unravel in the data world. So obviously, Redshift, Athena, Hive, these are data warehousing technologies, but we have to understand where does the data warehousing technologies fit in the entire data ecosystem, and what are the use cases? Why do we use data warehouse technologies even today? Now, not only that, we will also delve into other concepts like data mesh, data mart, etc., data lakehouse, because these are all related to each other. Now, the first thing that I want to talk about is the genesis of data, meaning how data is created. Now, in today's world, we have various ways using which data are generated. Now, the amount of data that is generated is pretty huge. We generate some exabytes of data in a year, maybe more than that. The question is, where do these data come from? Obviously, in our day-to-day life, the applications that we use, those applications generate data for us. For example, we use mobile applications a lot. We cannot think our life without a smartphone. We browse internet in mobile. We use mobile apps to place order for our stuffs. And let's say in Amazon, we use WhatsApp for communication. Almost all the business organizations that you can think today have mobile applications in some form or the other. So you cannot deny the fact that smartphones or mobile phones have become an integral part of our life, and we use that to generate a huge amount of data. So that's why I have put mobile applications at number 1 in the list. The second one is web applications. So web applications are typically the applications that we use using our laptop, iPad or tablet, etc., or our desktop if we have any. Now a lot of people use web applications also. Although mobile applications are pretty famous, web applications are also something that we use on a regular basis. We open our laptops, we open our desktops, we open the internet browser, open an application and do our stuff, and we generate data using web applications. Then we have bombardment of smart devices around us. We have smart TVs, smart watches, smart fridge, again anything that you can think of which has some form of compute or the other storing in that particular device or stored in that particular device is a smart device, and they generate huge amount of data. Let's take an example. Let's say we are using Fitbit or Apple Watch. We go for walk on a daily basis. Now what happens is that as we are taking walk, it actually using the sensor, it captures data that how much steps we are taking, and that data is sent to a backend system which creates analytics and dashboards for us, and we see that in our smartphones. So if you are using Apple phone, there's an application called Health, wherein we see in dashboards that how many steps you have taken a particular day, how many calories you have burned after doing an exercise, so on and so forth. Similarly, let's say smart TV. If we use smart TV, let's say we are watching YouTube in a smart TV, so it sends data to YouTube server. So again, all these smart devices generate huge amount of data as well. Then IoT devices, which are typically the sensors that we have around us. So temperature sensors, seismic sensors, sensors from vehicles, sensors from buildings, sensors from various infrastructure, so on and so forth. So all these generate data and send to a centralized location also. Electric vehicles, of course, we cannot deny the fact that we are in the midst of a revolution in the automotive industry, wherein electric vehicles are taking the charge. Tesla is pretty famous. Actually, Tesla started the revolution in electric vehicles, and we have lot of electric vehicles around the world. It can be four-wheelers, two-wheelers, three-wheelers, etc., and all of them generate data. The battery consumption data, the traffic data, how much battery is drained in a traffic condition. So some analytics that if I start my car and I go from, let's say, one place to another, how much battery would be consumed in that entire journey. So all these things generate data, sent to a backend server. These backend systems do some processing and send data back to us, which we see in our dashboards. And finally, of course, social media. We have YouTube, LinkedIn, Twitter, Facebook, Instagram, etc. All of them generate huge amount of data which are sent to their backend servers. And of course, analytics are done on top of these data. I must say that this is not an exhaustive list. This is a list of the most used applications in our day-to-day life which generate huge amount of data. So this is where we get our data from. These are the places that we get our data from. And once we get that data, then we send that data to various places and eventually to data warehouse, creating dashboards, etc. So let's take a look at how the data travels from one place to another, which is the data life cycle. As I have already told you, we have various sources where data gets generated. The previous slide talked about those various sources. We have IoT sensors, electric vehicles, self-driving cars which are sending video data continuously, mobile applications, web applications, smart devices, etc. These are all sources. These are some form of application or the other which generate data, and after generating the data, it has to be stored somewhere. So once the data is generated, we have to use that data, right? We cannot just discard that data. So after the data is generated, we somehow collect it. Now, how do we collect these data? We use various database technologies like relational database technologies, NoSQL database technologies. We use message broker like Kafka, Kinesis, which are real-time streaming ingestion. So if we have data which is getting generated continuously, that data is sent to message brokers instead of databases. And we can also collect data in data lakes. To give you an example, we have CCTV footages. So we have cameras in most of the traffic signals around the world. So what those cameras do, they capture real-time data, and those data are sent to again to a government server where the video is analyzed automatically, and if someone breaks traffic rules, they get notified. So now this can be a video image or a photo which is sent to the backend server. Now we cannot store images or video files in databases or message brokers. We store them in something called data lake. We'll talk about data lake in future slides. These are the various ways that we collect data from the sources. After that, what we do is that we process data. Now this processing layer is essentially called as ETL, which is extract, transform and load. Now we perform ETL operations on real-time data and batch data, video images, video files or images, etc. What do we do in this processing? We extract data from the source systems. So from the source systems, the data is collected into various storages like databases, message brokers and data lakes. We extract the data from here and we do some transformation. We use transformation platforms like Apache Spark, AWS Glue, etc. We do some transformation. We change the data or change the shape of the data, or we can enrich it with some other information. So let's say from the database I get some customer ID or my vehicle number. If you want to enrich that information, you pass that vehicle number to, let's say, another database where it stores the information of the owner. So that is called enrichment, because we just got the vehicle number, and from that vehicle number we enriched the data that okay, this he or she, this person is the owner of that particular vehicle. So this is called enrichment. We do enrichment also. Using processing layer, we can also do quality checks, do aggregations, etc. Right? After doing quality checks and aggregations, aggregations like how many times a particular vehicle has broken a signal, for example, or how many orders have been placed in this particular region. So these are called aggregations. So after doing all those, we load data to the downstream applications where we store again. Now, where do we store it? We can store it in a data warehouse, or we can send it to another message broker, because it is again doing some sort of real-time processing. We can store it in databases also. So I have not shown databases here, but we can store the data in databases also. Then you can store in data lake or data lakehouse. So this is where we store the data, and finally we analyze the data or we consume the data. So we analyze using, let's say, very beautiful dashboards or running SQL on top of the data. We get some insight from that particular data, what that data means after doing aggregation, after doing processing, or we can send it to machine learning applications also. Now, this entire life cycle from the source system to the target system, which is basically analyzing and consumption, this entire process is called a data engineering pipeline. This is just one pipeline. You can have various pipelines in your organization. So you can get data from different sources, store it in different databases or different data lakes, and then process in different ways, and then store it in different data warehouses or lake houses and analyze in different ways. So this entire data lifecycle is called a data engineering pipeline. Now in this course, we are going to talk about data warehouse essentially, which is basically AWS Redshift, AWS Amazon Athena, and Hive. Also on top of that, we'll talk about data lakes using AWS S3 or simple storage service. I'll also touch base on Lakehouse. Now let's discuss about this particular component, which is a database. Now what is this database? This is a very important component of an application. So any application that you create has to have one or more databases, which are called operational databases. These are also called OLTP, online transaction processing, because they store the transactional data. We use various types of databases here. As I said, database is very critical to a particular application, and database is something where data is born, because that's where you are storing the data. So these are called operational data stores because they help in day-to-day operations of a particular organization, because it runs the business. So these databases are used to run the business. You use various applications, mobile applications, web applications, smart devices, whatever. So when you use those applications, you generate data. Now those data are stored in these operational databases or OLTP databases. So in a way, these databases help us to run the business. So if any one of these databases are down in a particular organization, then all hell breaks loose, because these are very critical component for your business. These databases are running your business. Now, as you can imagine that these databases help in day-to-day processing also. So let's take example of an order processing, right? So let's say you are doing an online order. So once you place the order, that order has to be captured in a database. Once you make the payment has to be captured in a database. So if those things are not done, your business is not complete for a particular customer. So that's why these databases help in day-to-day processing. Using this day-to-day processing, what these databases do, these databases process transactions. So what are transactions? So we can take any example. It's not only monetary. So let's take various examples. So let's say you are withdrawing data using your debit card. So that's a transaction. You are buying a airline ticket using your credit card. That's another transaction. You want to see how much balance is there in your bank account, because you know your customer ID or you know your bank account ID. You want to see how much balance is there. That's also a transaction. Even though you are just reading information, that's fine, because that's a very critical information that you are trying to get. That's also a transaction. Now let's take some other examples. So let's say Uber. Most of us have used cab aggregators like Uber. Now let's say you have placed a query to find a cab. That's again a transaction. Now you book a cab. That's another transaction. Let's take example of online buying, Amazon retail, amazon.com, amazon.in, whatever. So you have placed an order. That's a transaction. You are searching for a product. That is another transaction. So I think you have, by now you have understood that what databases do. Now all these transactions are backed by the databases. So that's why these are called database transactions. The information that you are trying to find, we get those information from databases. The information that you are storing, that we are modifying. So let's say I have withdrawn amount from my bank account. That's a debit that I have done from my account balance. That's a monetary transaction. That's a financial transaction that is stored in database. So essentially these operational databases or OLTP databases process these transactions or process database transactions. Now in OLTP databases, as you can imagine, that the data comes in, and this is where data are born or data is born, because these databases are being interfaced by the applications that I have mentioned in the first slide. So all these applications generate data, or most of these applications generate data and put data in the database. The moment you put data in the database, your data is born. So the data is coming in your operational or OLTP databases. So that's why this is where data is born. If you think about whatever examples I have given, this is all about current data. Whatever you are doing today, whatever you have done yesterday or day before yesterday, these are all current data. Of course, whether the data is current or not, that is defined by a business. I mean, how far back data can be current. But whatever the duration is, that current data are stored in operational data stores or OLTP databases only. One more feature or highlight about OLTP databases is that it handles high concurrency. So you can have thousands to millions of users and queries, because let's say I have a bank account in some bank, and of course thousands of other people can have bank account, and all of us can be doing some processing or the other. These operational databases handle high concurrency. So thousands to millions of users do processing some sort of transaction or the other using these databases. And the queries are very simple. Get me the account balance, debit from my account, credit to my account, place an order, search a product, so on and so forth. So these, as you can see, these are very simple queries which affect output rows, which can be in the range of ones to tens to hundreds. So if you do a query in these operational data stores, the output that you see is not huge. So the result that you get is very short in size or very small in size. You do not get millions or thousands of rows, right? You get only few ones to tens to hundreds of rows. So the output rows are very limited from the operational data stores. The operations are of course small. Both read and write are small operations because they use simple queries, and also the affected rows, the number of affected rows are also small. So the operations essentially are small as well. One very important attribute of these databases are that the response times or the processing time are in milliseconds. It can be in a few seconds, but not more than that. So that is another important attribute of operational databases or OLTP databases. And typically the size of OLTP databases can be hundreds of gigabytes or units of terabytes, meaning 1 terabyte, 2 terabytes, 4 terabytes. But if it is more than that, then you should be worried about your operational data stores. Your operational data stores should not be in tens of terabytes. It should be maximum, let's say 4 to 5 to 6 terabytes. That is fine, but not more than that. So these are the highlights or the characteristics of operational or OLTP databases. Now see which database technologies fall in this OLTP category. So in the relational world, we have MySQL, PostgreSQL. These two are open source. And in the licensed version, we have Oracle, DB2 and SQL Server. So these are the main relational OLTP databases or SQL OLTP databases. Then in the NoSQL world, we have MongoDB, DynamoDB, Cassandra, and Redis. MongoDB is a document-oriented database. DynamoDB is a key-value data store. Cassandra is wide column data store, and Redis is in-memory database. So these are various operational databases that you can see. You cannot use DynamoDB for anything other than operational or OLTP databases. Same is the case with Cassandra or Redis. You cannot use Redis for anything other than OLTP databases. You cannot use DB2 LUW for anything other than OLTP databases. Of course, all these relational databases that you see, MySQL, Postgres, Oracle, all of them have OLAP, online analytical processing or data warehousing systems also, but their main flavor is in the OLTP data store. Now, as far as NoSQL databases go, DynamoDB, Cassandra, and Redis are strictly for OLTP databases. MongoDB can be used for analytical use cases also. Of course, this is not an exhaustive list. There are other databases also, but these are the most famous ones. Now on the AWS side, AWS provides RDS and Aurora for relational or SQL databases. DocumentDB is a MongoDB compatible database. DynamoDB is essentially AWS's key value store. For Cassandra, we have Amazon Key Spaces, and for Redis, we have a managed service called Amazon Elasticache. So these are all the operational or OLTP databases that AWS provide. Next, we have analytical databases or OLAP, online analytical processing, that is OLAP. Now, data warehousing systems also fall in this category. Now, the first important characteristic of analytical databases is that they do historical processing, meaning there would be huge amount of data in these databases. It will have history of your transactions. So typically the transactions or the records that are there in OLTP databases would be pulled in analytical databases, and older records would be deleted from the OLTP databases. Now it is used to analyze the business, to see what is the health of the business, where the business is going, what are the growth opportunities, which customer we should target to, which region we should target to, which product are famous, and which product would fetch a particular business more revenue, so on and so forth. So analytical databases are used to analyze the business as a whole, to give a holistic view of the health of the business or the organization. Now, as I already told you, it stores historical data. Now, data goes out of the analytical database because data comes in OLTP databases. Then from OLTP databases, we move to analytical databases. And from there, we generate reports and analyze the business, which is essentially data is going out for consumption. So OLAP or analytical databases are the places where data actually goes out of the system for further consumption. And another characteristic is that the concurrency is lower. It can be from tens to few thousands. Definitely it cannot be in millions, because again, we are analyzing the business. It is for historical processing. So we cannot have huge concurrent users or highly concurrent queries running on analytical databases or data warehouse systems. Analytical databases or warehouse databases handle very complex queries. So we'll be having joins with maybe 6, 7, 8 tables. So joins like SQL joins that we have already talked about in the SQL section. So it can be inner join, left outer join, right outer join. It can be anything, but with a large amount of tables and with large amount of data. So the output rows can be in tens of thousands, because we are getting a holistic view of our business, of our customers, of our organization, etc. So we cannot contain it in small number of rows. The number of rows are typically pretty high because the queries are complex, the data is also pretty high. Now, in analytical or data warehouse systems, we mostly use or run read operations. The write operations are very less, those happen in batch or in streaming also, but we should not do too many write operations in analytical databases. When I say write operations, I mean small write operations like inserting a single row, updating a single row, deleting a single row. So we can delete magnitude of rows, we can update a lot of rows together in a batch, we can insert a lot of rows together in a batch also, but we should not do it like operational databases or OLTP databases where we update a lot of rows concurrently, lot of different rows concurrently. So here typically we write just that one time and we read that data multiple times. The processing time can be from seconds to hours also, because as you can see that the output rows can be in tens of thousands. So we cannot expect those records to be returned in milliseconds, like in the case of OLTP databases. So that's why typically the processing time can be from seconds to hours. In some cases, in old systems, I have seen even days also, which does not happen that often in today's environments. And the data size can be from tens of terabytes to petabytes also. Redshift, which is this course based on, can handle petabytes of data. Now, where do we use these analytical databases? We use this for marketing, sales, campaign, because as I said, we get insight of the business. We get an holistic view of the entire organization and the business. And based on that, we can take strategic marketing decisions or sales decisions or campaign decisions. We can check the performance of the business that I have already talked about in the previous slide. We can combine data from various diverse sources. So we can have multiple OLTP databases, we can have SQL databases, NoSQL databases, OLTP databases. We can have streaming data also. And what we do is that we get all those data, do some processing, combine them and put them in analytical databases. The number of analytical databases or clusters are typically very low, but number of OLTP databases can be very high. So using analytical databases, we learn about the business and gain intelligence on various business activities. So let's say you have a product shop. So you want to see which product is getting sold where. So let's say we want to find out which region is buying a particular branded product. So if we see that one particular region is buying one set of product more than the other region, then what we'll do is that I'll send more inventory to that particular region so that the products never go out of the shop. And one of the very important thing that we do using analytical databases is analytics and reporting. So these analytical databases or OLAP databases are called data warehouse. Now, what are the technologies that we have in data warehouse? Of course, we have Amazon Redshift. From Azure, we have Synapse. From Google Cloud, we have BigQuery. And from Oracle, we have Exadata. Apart from that, we have Teradata. We have Databricks also. Snowflake, which as I said, it has gained good momentum in recent days. Greenplum, which is a fork of Postgres. By the way, Redshift is also a fork of Postgres, but it diverges drastically. Then Athena, which can be thought of as a data warehouse, but it is not used completely as a data warehouse per se, which we'll discuss in our second topic, that is Athena. Also Hive, which is our third topic. Now we get the data in using OLTP databases, and we move the data or take the data from OLTP databases to OLAP databases or data warehouses. So from operational databases to data warehousing systems. Now the question is, how do you do the movement? As I already told you, the size of OLTP databases should not be big. It can be few hundred GBs to units of terabytes, let's say 2 terabytes, 4 terabytes, etc. It should not be more than that. But your data warehousing systems or OLAP databases can have huge amount of data, like tens of terabytes, hundreds of terabytes to petabytes also. How do you do the movement from OLTP to OLAP? We use the process called ETL, or extract, transform and load. So this is a very well-known process which is used to move data from one place to another. So in this case, we move data from OLTP databases to OLAP databases. After extraction, we do the processing of data, which is also called transformation. And we use technologies like Apache Spark, AWS Glue, etc. to do the transformation as we need or as the business needs, and then move the data or load the data to the target system, which is our data warehousing environment. So let's say we have source systems like, or source database systems, SQL OLTP database, which is RDS MySQL, and NoSQL OLTP database, which is DynamoDB. So what we do is that we extract the record using the ETL process, do the processing, which is basically multiple transformations, and load the data in data warehousing systems or OLAP databases like Redshift. After we move it to Redshift, then it is used by the downstream systems like analytics, reports, machine learning, etc., which use data that has been loaded in data warehousing systems like Redshift. Again, this is a very high level overview. Of course, I'll go deeper into this process later on. In this course, I'll mostly talk about Redshift, but I'll also show you using hands-on how do you extract data from these source systems, from these OLTP databases, run some processing, and then move it to data warehousing systems like Redshift. Now, as far as processing is concerned, we use tools or platforms like AWS Glue, Apache Spark on Amazon EMR, or Zero ETL process. I'll show you all these three at a high level. It's basically AWS Glue and Spark on high level, but we'll go deeper into Zero ETL. I have another course which is Data Engineering on AWS Volume 2. That's where we talk about the processing in much more detail. So I cover AWS Glue and Spark on EMR in much more detail there. So please take a look at that. And as far as reporting is concerned, on AWS we have a tool like Amazon QuickSight. So there are other tools also like Tableau, Qlik, Microsoft's Power BI, etc., which have connectivity or connector to Redshift. So we can use these other tools also to connect to Redshift and create reports out of it.